Friends, I decided to record this video when a technically savvy client approached me for an independent advice on how to improve the air quality in her private house. The house is naturally ventilated and has modern double glazed wooden windows. The client was not from the HVAC industry, but regularly measured the CO2 level in their home. And of course noticed that the carbon dioxide levels in their home often exceeded the recommended levels. If the topic of improving indoor climate in your home or office is also relevant, you may find this video useful. So first of all, why exactly do we need ventilation? Any kind of ventilation. I will put some examples with numbers here, and I think that this should close any questions on this topic. Let's imagine small bedroom, for example 12 square meters, and two people are closing their windows and going to sleep. The volume of this room will be approximately 32 cubic meters. An average human with normal health conditions in a steady state, so when he doesn't do any workout or running or triathlon, consumes approximately 250 milliliters of oxygen per minute. Knowing that, it's easy to calculate that the bottom level of the bottom healthy level of oxygen, which is 19.5% in the air, will be achieved in this room in approximately 8 hours. And which is more important, it's the level of our exhaust, the CO2. And in this room, two people will increase the CO2 from quite normal level of 500 ppm to unhealthy level of 2000 ppm in about 2 hours, depending on the infiltration rate from other rooms. A few years ago, we've conducted an experiment in our office. We've started a meeting with 12 persons in a closed room. The room area was about 25 square meters. And we have started the meeting and put the carbon dioxide sensor in the table. So can you imagine that the CO2 levels have grown from the starting point of 650 ppm up to 900 ppm in about 15 minutes. After 30 minutes, we've already had 1200 ppm. And in about 45 minutes from the start of the meeting, the carbon dioxide level was 1800 ppm. Most of participants stated that they are starting to feel already some drowsiness and fatigue. So soon after that, we have finished our experiment because most of the people would like to escape this room. Usually when the CO2 level is increasing up to 2000 ppm, productivity and the well-being is significantly reduced. So if you are thinking about productive, healthy environment, some kind of ventilation is a thing that you just can't avoid. It's obvious. Okay, let's discuss the most common ways of ventilations that have been used in a modern world. These are natural ventilation and mechanical ventilation. The natural ventilation is the most old way of ventilating premises. It's a way in which air exchange is performed without any mechanical devices, using only laws of physics. It is based on the fresh air supply through the windows or through some kind of openings in the wall or untightness in the external building construction, and the air is extracted with the help of centralized shafts. When using this kind of ventilation, it only occurs when the supply air and the ventilation draft in the shafts are sufficient. This can only happen when the indoor and outdoor air temperature difference is quite big, so in cold season, and when the wind direction is favorable. In other cases, their supply and ventilation draft in shafts will be insufficient, and you will need to open windows to increase direct air exchange between indoors and outdoors. It's an important case for post-Soviet countries where millions of people lived and millions of people still live in standardized buildings which were built using natural ventilation. These buildings were designed such a way that untight windows provided supply and the air was extracted via centralized shaft in bathrooms and kitchens. In the late 90s and early 2000s, when energy prices became high and modern tight plastic windows fulfilled the market, people became replacing the old wooden untight windows in huge numbers. And of course, with this approach, ventilation in those apartments was completely turned off, which will lead to another big problems. It's a mold growth. In the end of the video, I'll give some advices how to improve natural ventilation if you have one and don't satisfied with this with its efficiency. The term mechanical ventilation implies a process in which air is driven by mechanisms, and the air is driven by fans. This can be extract ventilation when the fan is located before shaft or on the roof, and the air supply or compensation is provided by system imbalance, so from other ventilation system or from window or from openings or from other premises. These can be specific smoke extract and overpressure systems which have been used in civil constructions to decrease risks for people during fires. And the most well-known and quite highly developed is modern balanced supply extract ventilation with heat recovery. It is a quite complicated system with ducts where air is supplied and extracted from dedicated premises. For example, air supply can be located in living rooms and bedrooms, and extract diffusers are put in kitchens and bathrooms. When using this type of equipment, the extract air, the warm extract air, which has temperature of the room, is giving away a big part of his energy to the outdoor air when it's going through the heat exchanger. This is called thermal efficiency of heat exchanger. For modern units, usually it is somewhat from 70 up to 90%. So we are heating the air, and when it is thrown away to the outdoors, for example, 75% of its heat will be transferred to intake fresh air. Okay, so if you are thinking which ventilation system to implement in your private house, apartments or office, let's take simple initial cost and life cycle cost calculation with natural and mechanical typical ventilation. I've prepared a small spreadsheet for you for a fast calculation. Let's say we have a private house with area above average, which is located in a moderate climate. Let's say it can be Scandinavia or Baltic countries, maybe northern part of Central Europe. The average air temperature during the heating season 0 degrees Celsius. Average heating season duration will be half a year. Supply air temperature needed 22 degrees Celsius. type of the heating coil electric. When you're building, you can choose also water, but we will, just for simplicity, we'll take electrical. Price of electric energy per 1 kilowatt is 1 kilowatt hour, 20 cents, euro cents. So let's say air exchange, the necessary air exchange is 500 cubic meters per hour. And let's imagine that in some way the natural ventilation with which we are comparing this system is also eligible for maintaining such air exchange. Electrical power for air heating will be electrical fan power, it is about 40 watts per one fan, so 80 watts per unit, per air handling unit. Efficiency of heat exchanger is taken 75%. It's some kind of average energy efficiency for modern air handling units, for the average air parameters. The efficiency of heat exchanger decreases when temperature decreases temperature difference. Required power for air heating is 3.7 kilowatts when we doesn't have recuperation, any kind of heat exchange, and less than 1 kilowatt, so 925 watts in case when we have air handling unit with heat exchanger. Energy consumed during the heating season, so it will be 4,000 and 15,000, almost 16,000, almost 16 megawatt hours in case of natural ventilation, and 4.3 megawatt hours in case of air handling unit. Price of electric energy consumed during the season, so we have here for the air handling unit about 868 euros and 3,000 almost 200 euros in case when we have natural ventilation. But we are assumed that this natural ventilation maintains the necessary air flow for a good, healthy environment. Well, initial cost for building such a system, I took just from experience 6,000 euros. It's just ventilation handling unit with installation, and 300 units for natural ventilation. So it can imply maybe some valves in the outdoor walls, or valves in the windows. Yearly maintenance cost 300 euros, so it's cleaning, filter change for the air handling unit, and let's say 50 euros on the cleaning of the shaft. I did a fast life cycle cost calculation, taking a discount rate 5%. And we see that this quite expensive from the very beginning mechanical ventilation system cost us more than natural ventilation system. It cost more in first year. You see, 6,800 euros against 3.3 thousand euros. In the second year, but the difference is already less, and you see in the end of third year, the ventilation, mechanical ventilation system costs less, and for example, after 5 years, the difference is already almost 30% between them. So the mechanical ventilation system initial cost, of course, are much higher, but even after 5 years, life cycle cost of such system is significantly lower than natural ventilation system, which provides the same air exchange. Here we can see this on the chart. Correct. So in the third year, we have the point of cost efficiency of mechanical ventilation compared to natural ventilation system. And as I promised before, in case if you don't have enough space to install mechanical ventilation system, you don't have space, or you don't want to execute all those building construction works, how can you boost the existing natural ventilation system? So of course it's quite well known extract fans, which can be put on the shafts. Many people are using in kitchens for better air exchange when cooking. They're using kitchen hoods, but of course not all the people know that the kitchen hood power is quite big, and it just can't to take all the necessary air from this room. It doesn't have supply. So when you are turning on the extract kitchen hood, which is connected to shafts, you need to open the window if you don't have other supply devices. The other thing which also can be used, it's supply valve in the wall. It's also can be a solution in which outside air is going into the room through the radiator. It's quite good solution because you don't have cold air is going inside you. So this room is going through the radiator before it enters the living zone, and it is being preheated, and when it comes to the room, it's already has comfort temperature. And the other solution which became quite popular in the last 5, maybe 8 years, it is decentralized ventilation using valves in the wall with fans and heat exchangers. Usually manufacturers recommend to put them in pairs, so one room, one pair of such equipment, and they are able to work together. So one time the one device is supplying air inside, other device is executing extract of the air. By this time their heat exchangers for supply device, this heat exchanger is giving it heat to the outdoor air. After some time those devices are reversing their flows, and the heat which was absorbed during air extract in the extract device is giving is transferring to the intake air. Well, those units provide some kind of energy efficiency. I don't know, they are in the market, are not so very popular because of the price. If you want to equip all the rooms with such equipment and you have plenty of rooms, then probably you will pay more than the conventional ventilation supply extract ventilation system will cost. And you'll put in your house plenty of fans which sometimes will need maintenance, and in one time those bearings will wear off, and you will need just to replace the fans or all the equipment. To summarize shortly, if you are building or rebuilding a house, flat or office, then definitely consider the supply and exhaust ventilation with a heat recovery. If you are determined to improve the microclimate in rooms where there is already a good finish and cannot or do not want to do a lot of renovation work, consider decentralized ventilation with wall recuperators. If your budget is limited and you wish to retain the principles of natural ventilation, improve it with an adequate air supply and, if necessary, an extract fan. However, keep in mind that this is the most disadvantageous ventilation system in the long term. So I hope this information was useful for you, and now you have some kind of information, maybe starting point to think about your preferred way of ventilation. Anyway, if you have some questions or doubts or comments, leave a comment below. Let's have a discussion there, and see you in the next video.